Hi, everyone. Welcome to the Art of the Possible series. I'm Nihali Niyogi, and I'm a Principal Cloud Solution Architect at Microsoft, focused on advanced networking. In this video, we will be talking about Palo Alto VM series firewall in Azure. In the previous video, we had covered the cloud NGFW, so be sure to check that out. Today, we will start with Bala from Palo Alto, followed by architecture overview and demo with Daniel. And later in the video, we have advanced scenario presentation with Shruti, Cynthia, and David and Mace. We will go through a quick round of introduction. Bala will start with you, and then we'll go with the Microsoft SMEs.
All right. Thanks, Nehali. Hi, everyone. My name is Bala Mainini. I'm a senior technical marketing engineer here at Palo Alto Networks, and I mainly take care of our VM series firewalls across public clouds and private clouds. And I'm so excited to talk to you all about our VM series firewalls offerings on Azure Cloud and some of the deployment scenarios. Why would you need VM series firewalls on Azure? What are the different options do we have with respect to deployment, all those scenarios, and I'll be able to talk to you about all of those scenarios. Thanks for having me here, and I'll hand it off to Microsoft team for their introductions.
Okay, hi everyone. I'm Cynthia. I'm part of the Global Black Belt team, specialized in Azure networking, and I'm covering EMEA.
I can go next. Daniel Mauser. I'm solutions engineer, part of the oil and gas industry, and yeah, I'm fine and happy to be here.
Excellent. Welcome, everyone. And with that, Bala, we turn it over to you for the presentation.
Yeah, absolutely. Thanks, Nehali. So in this presentation, obviously, we will be focusing on our VM series firewalls on Azure Cloud. But before that, just wanted to give a brief overview of what exactly are software firewalls, why do we need software firewalls in the cloud, and what are the advantages of value add that software firewalls bring in to the public cloud. Let's get started. So when we think about almost, I think close to 10, 15 years ago, we used to have all our applications and workloads in the traditional data center. But obviously after that, we have seen a huge shift towards public cloud migration. Obviously from the data centers have started to get virtualized, and a lot of enterprises have started to move their applications or workloads from data centers to the public cloud. Well, obviously now we have more than one cloud, so enterprises mostly have applications sitting in multiple cloud. But when we think about how the workloads or applications can be secured, the application or workload can be anywhere. It could be in a data center, it could be in a virtualized form factor, or it could also be in public cloud or even multi-cloud. So our software firewalls can protect the workloads or assets sitting anywhere from data center virtualization in a virtualized form factor to public cloud. And even if you have assets running in multi-cloud, we can have our software firewalls deployed in any cloud, and they will help secure your workloads or assets. But just to understand the growth from data center virtualization to the public cloud, and also now we are all aware of the AI infrastructure every enterprise is building, it does bring in some additional risks with respect to security attacks attacking these specific workloads or applications. When we have applications or workloads which are spread across multiple platforms or multiple clouds, be it in data center, be it in public cloud, the attack surface has drastically increased. And we from Palo Alto Networks see close to 9 million unique zero-day attacks every single day. And obviously, the attacks from the past 3 or 4 years have increased almost 4x, 5x, etc. Now, obviously, from the past few years, with the increase in building out the AI infrastructure for every enterprise, that also does bring in more risks associated with that AI infrastructure. So we are seeing a huge shift towards securing these environments, especially the cloud environments or data center environments, where these critical applications are sitting. So what I would like to emphasize is since the infrastructure has been growing like so rapidly, which means that the complexity has increased pretty drastically, there is a need for securing all of your workloads or assets in pretty much a uniform with an enforcement of uniform security policies across every platform to make sure that you get that consistent security across multiple platforms. And obviously, we have also seen with the complexity, the security operations have also become so complex. So we have a need to kind of like have the security infrastructure kind of like so sophisticated so that we avoid any necessary complexity between like data centers and public cloud in securing these environments. Now let's talk about a quick overview of our software firewalls. Obviously, I think this is something which most of the folks might be aware of, but just wanted to give a quick overview of what exactly software firewalls do and why do you need them in the public cloud. So you might be having a lot of applications sitting in the public cloud. And when these applications, like for example, these applications might want to talk to the internet, for example, to get some software updates or to read some websites or some URLs from those applications. But when we are reaching out to the internet, those applications might be exposed to so many different attacks, so many different risks, and there is a need to protect the outbound connections or the outbound traffic from the application sitting in the cloud environment. And that's our first use case, which we would be protecting from Palo Alto Networks, where your outbound traffic from your application is secure by using our software firewalls. Obviously, we club our software firewalls with our advanced subscriptions, which provide best-in-class security protection for your workloads and assets. Our advanced subscriptions include advanced threat prevention, advanced wildfire, advanced URL filtering to make sure that your applications or assets are not accessing any malicious URLs. And then we also have advanced DNS, DLP, etc. as well, just to prevent you from any of those sophisticated or zero-day attacks. Similarly, if you have users, remote users or users sitting behind a data center who would want to reach these applications, and that's we wanted to make sure that there's only genuine users or genuine applications who has access to those applications are only able to access those applications so that we constantly monitor the ingress traffic to these applications. And that's our inbound use case where our software firewalls protect the workloads and assets from any inbound connections, pretty much inspecting all the traffic that is passing or by receiving, which are being intended to the destination, which is our assets and workloads. Similarly, are one of the most important use cases when we have different workloads sitting probably in multiple VNets. Those workloads would want to communicate with each other. At the same time, when the lateral threat movement is something which is very critical in an enterprise, we wanted to make sure that, for example, if there's any workload or asset affected with a threat, that thread doesn't propagate to other VNets or other workloads sitting in the different VNets. And that's the use case with lateral threat movement with our east-west traffic use case. And we wanted to make sure that the lateral threat movement is stopped and our software firewalls can pretty much inspect the traffic across multiple workloads in a single VNet or multiple VNets, and we can have the traffic inspected between the workloads as well, which is our east-west use case. So here, obviously, the software firewalls deployed in the cloud will protect the workloads and assets from the outbound traffic, inbound traffic, as well as east-west traffic, which is our three main use cases of having software firewalls in the cloud. Now, quickly looking at the Palo Alto Networks platform, I'm not going to spend too much time on it. Obviously, Palo Alto Networks has our best-in-class platform where we can have it acts as a single sensor. Obviously, we can see that we have software firewalls, And then it is powered by our advanced subscriptions, like we just spoke about, which is all controlled. Your software firewall can be deployed anywhere. It could be deployed in a VM form factor. It can be deployed in a CN form factor, cloud native, AR runtime security. But your uniform management engine, which is our Strata Cloud Manager, acts as a single sensor to kind of like push the policies across multiple firewalls, be it in data center, be it in public cloud, etc. But it make sure we can make sure that we have the consistent policy enforcement across every firewall, irrespective of where the firewall is deployed. Obviously, this slide talks about our orchestration engine, which is our Panorama and Strata Cloud Manager, where we can achieve the consistent policy enforcement across multiple firewalls, irrespective of where the firewalls are currently sitting. Now, just quickly going over the overview of our VM series firewalls. Now, let's look at, we know that like part of software firewalls, we have different form factors. We have our VM form factor. We have our cloud next generation firewall, which is a completely a SaaS service, which is completely managed by Palo Alto Networks. And we have container form factor as well. So in this presentation, we'll be mainly focusing on our VM series firewalls. So VM series firewalls are self-managed firewalls. The difference between VM series and cloud next generation firewall or VM series is completely self-managed by the customer, whereas the cloud next generation firewall is a SaaS service completely managed by Palo Alto Networks, would be deployed in Palo Alto Networks account. But VM series, the customer would be having complete control of their firewall. They can pick what subscriptions they would like to have part of the VM firewall. They can pick the licenses that they would like to deploy on the VM firewall. Again, we'll be talking about the licensing as well in our next slides. But mainly, the VM series is a self-managed, completely self-managed firewall by the customer. It can run on any cloud, any hypervisor, be it public cloud, be it data center, can be deployed anywhere, which means that if you have workloads spread across multiple environments, you can have our VM series firewalls deployed on like in those different environments to protect the workloads and assets. At the same time, what the most powerful asset of our VM series firewall is you can use some of your automation tools, like for example, Terraform, to have the VM series firewalls deployed across public clouds as well as private clouds. You can pretty much automate your deployment process, including the architecture, deployment of the firewall, etc. The licensing model is something which is very much similar to our cloud-like consumption. Like, for example, we support two licensing models on our VM series firewall. For the customers who would want to have native cloud-like consumption model, for example, something similar to pay-as-you-go, we also offer VM series licensing for pay-as-you-go as well. And the other licensing model is we also offer credits where the customer can purchase and use those credits to deploy a VM series firewall. And those credits would be consumed for the licenses depending on how many subscriptions, what's the form factor of the VM series firewall, how many cores are being used. Depending on that, the credits will be consumed from the credit pool as well. Now, let's talk about some of the main public cloud use cases. I know like we just spoke about why software firewalls are needed in the cloud, but obviously when we have our VM firewall deployed in the public cloud, especially on Azure, we can have it act as a perimeter firewall for your protection of your workloads and assets. We discussed about the outbound and inbound use cases. Like, for example, if you have any assets sitting in the specific VNet, you can have those specific outbound and inbound traffic inspected by the VM series firewalls. It also offers the segmentation across multiple VNets, which are multiple VNets or multiple workloads. And obviously, it prevents the lateral threat movement. And obviously, we have the multi-cloud security, which offers the security across multiple clouds as well. Just to kind of like spend a little bit more time on the licensing options, like we just spoke about, we have our bring your own license, which is similar to the Flex credits licensing model that I just spoke about. where the customer can purchase certain set of credits, and that will be allocated to a credit pool. And the customer can spin up a deployment profile from the customer support portal, which will offer the customer to select different options like what are the number of cores that they would want to select part of the VM firewall, what are the subscriptions that they would want to have. Like, for example, if the customer's use case is only outbound, they only want the outbound traffic to be secured, they can select these subscriptions appropriately, and the deployment profile should show how many credits would be consumed for that particular VM firewall with the subscription selected, and it would give out the licensing information, which can be inputted part of the deployment process, or it can also be bootstrapped with the deployment of the VM firewall. And obviously, we have pay as you go, which is the easiest licensing model. Obviously, from the marketplace, the customer can select bundle one or bundle two. On Azure, we offer two bundles, and the customer can select either bundle one or bundle two. The main differences between bundle one and bundle two are the set of subscriptions that we offer per the bundle, and depending on what subscriptions that the customer is interested in, they can pick a specific bundle, and it'll be charged based on like per hour basis for the cost. Um, Next, I just wanted to quickly talk about our VM series firewall deployment on Azure and how we simplified the process. I think we also have a lab later in the session, but just to kind of like give a quick overview of how easy it is to deploy the VM firewall on Azure environment. Like, for example, if the customer has already their applications in specific VNets, and let's say they do not have any firewall protection today, if they want to secure these workloads and assets, they do not have to worry about any configuration. Like, for example, the common deployment model that we follow in public cloud is a centralized security deployment for the firewall, which means that you would have to deploy a firewall in a centralized VNet and obviously have the connectivity between the VNets to the security VNet, and then have the traffic sent to the security VNet for traffic inspection. But to have the security VNet, there are multiple resources which are needed. Like, for example, you would need a load balancer, which is on the ingress side, which can act as the entry point of the traffic, where from the applications you can point your traffic to the front end IP of the load balancer, and then the load balancer would load balance the traffic across multiple VM series firewalls in the backend. But obviously, kind of like configuring all of this manually would take a lot of time. So that's the reason what we have introduced is our predefined solution templates, where the customer can define how the architecture should look like. And once they deploy this directly from Azure Marketplace, all the resources which are needed for that VNet would be deployed. This would include your load balancers. This would include your VM firewalls. If you want a load balancer sandwich design, we can also deploy that. So there are multiple architectures that we support part of the Azure solution templates. So anyone who would want to deploy the VM firewall in a topology form factor and point the traffic from their application VNets to the security VNet for inspection, they can pretty much do that very easily and would save a lot of time. And obviously, we could have the solution template deployed in about like 30 to 45 minutes, and then we can have the traffic pointed to the load balancer IP. We can create a UDR from the application VNets to point it to the front end IP of the load balancers, which would have the traffic sent to the security VNet. And from a configuration perspective, from the resource deployment perspective, everything would be taken care by the solution templates. This is one of the common deployment architecture that is supported by the solution template. Like I mentioned here, we have our ingress load balancer, and then we have our VM firewalls, and then we have our egress load balancer as well, which is present in the public subnet. So your application VNets would be sitting somewhere in the backend of in the cloud. And if you want the application VNets to be secure, anyone can point the traffic to the front end IP of the load balancer, which would take care of load balancing the traffic to the VM firewalls. So everything that you see part of this VNet, which is the security VNet, is deployed and configured by the solution template. Obviously, we have some of the goals for our solution template, which is the firewall configuration. You can also have a default configuration option selected during the deployment, which would pretty much configure your security policy, your the policy for your health probes or for your Azure load balancer. So anything that you would want to get started with would already be configured by default, and you can have your outbound traffic and east-west traffic inspected. Um, I also have a link to our solution templates, which points to our documentation page. And here you would see pretty much all the different deployment architectures that are supported from the Azure Marketplace, which can be deployed readily and is available now. And anyone can go ahead and deploy that. All right, with that, I'll hand it over to Nihali. That's all I wanted to cover, Nihali. But if in case of any questions or if in case of any additional information, I'm happy to provide that.
Thank you, Bala. Excellent presentation. Yeah, so I did have some questions on licensing, but we will look at it when we deploy the template.
Yep, absolutely.
Okay, so we'll start with what our default architecture is usually on these sessions is the right side being the Azure hub spoke architecture and the left side being a data center connected with some sort of private connectivity. And what, like Bala mentioned, we will be deploying the firewall in this hub VNet. So with that, let's go ahead and kick off the deployment as it will take a few minutes. So I'm going to go to the Azure portal. I'm in the create resource here, create resource, and then we'll search for Palo Alto Firewall. And here we are in the different type of Palo Alto offerings. Bala, I think you can correct me if I'm wrong, but we would be picking this one, the VM series high resiliency with load balancer.
Yeah, that's right, Nihali. Also, just to kind of like give a quick overview of the different offerings, like we see here, we have our VM firewall offerings, we have Panorama Cloud Next Generation Firewall, but this offering that you selected gives an option to deploy the predefined solution template. You can deploy a single VM firewall, or you can also deploy multiple VM firewalls, which would always act as in active fashion, which is front-ended by a load balancer, and that would be one of the recommended approaches or recommended deployment practices for our customers.
Awesome. Thank you. Yeah, so let's go ahead and kick off this deployment as it would take a few minutes, and then we'll come back and revisit some of the licensing question, if that's okay. So I'll go ahead and put this in a resource group. We'll call this, and we'll pick East US, and we'll pick Holly here. Well, I do want to come back and revisit this drop down, but I'll first go ahead and go ahead and kick it off so that by the time we talk through it, it can progress. Okay, so we'll come back and revisit this. Sorry?
Also for the licensing type, Nihali, let's select bundle one. The reason being is that for your bring your own license, we would need the licensing information which is provided from the customer support portal. I can show how, like for example, if, like later in the presentation, if we have time, I can also show for BYOL how do we fetch the licensing. What are the different licensing steps that we need to make sure for BYOL? Like I mentioned, we need to have a deployment profile. I can kind of like show that as well if we have time.
Sure. So for bundle, we have been testing it with BYOL. For bundle one, do we need a Palo Alto account or something, or would it work with?
No, yeah, it should work actually.
Okay, perfect. Yeah, I think we do want to do a deep dive at some point on this particular drop down, but for now we can pick that one. And then here there is an option to if I hover over this eye, it does say that I could bring my own VNet, but we haven't been able to test with that. We were not getting the drop down for our own VNet, so we can take that offline, Vala,
Yeah.
if you want.
Yeah.
But for now, because we did create this three subnets: management, public, and private, but we
Understood.
were not able to see the drop down over here.
Understood. So actually, one quick note there, Nihali. So, I mean, from a general practice, best practices point of view, it's always good to create a new virtual network from this workflow so that we know that, hey, like this is something which is new. We are pretty sure that there are no existing resources in
Mhm.
that specific VNet, which is kind of like very important for our firewall deployment. So, but you can also choose the existing VNet, but again, like if there are any resources that would kind of like get it might get mixed up. So it's always a best practice to deploy a new firewall VNet from this workflow.
Definitely, yeah. I mean, if there is a brownfield environment, though,
Yeah.
we would like to know if there is indeed an option through that workflow.
Mhm.
Um, because unless they point the UDRs to the load balancer, the
Mhm.
traffic would not flow through the firewall. But it
Correct.
does look like there is a way to do it, but
Mhm.
we weren't able to figure that out. So
Can you
we'll,
click on edit virtual network, Nihali, once? So I think probably from here. Oh, I see. This is for the new VNet. Okay, never mind.
yeah,
You
yeah.
can cancel.
Yeah, we can take that
Yeah.
one offline. Yeah. Okay,
And if
so
you click the deployment architecture drop down, that's the different deployment architectures that I was talking about. We totally support up to 4 deployment architectures, depending on the customer use case on how many firewalls they would like to have. We can have from all the way from 2 firewalls to 4 firewalls, and you can have dedicated firewalls for your inbound or outbound use cases.
yes, so here we will pick a common set with load balancer, so we could use that for both east, west, and north, south, right?
Correct. Yeah, absolutely.
Yeah. Okay.
So
All right.
that's
And
the architecture that I was showing in the slide, where it will
mhm,
be deploying the firewalls, 2 VM series firewalls in a load balancer sandwich design.
perfect. Yeah. So let's go with this one. And then we'll use create the new VNet, and under the hood it creates management, public, and private subnets. And then we'll go pick. Yeah, maybe this is a good point to talk about.
So high resiliency option would always deploy more than one. And in this deployment architecture that we have selected, part of the template would deploy 2 VM series firewalls in active-active, which is sandwiched between the 2 load balancers. And in this page, you have an option to select the VM series version. Obviously, in the drop-down menu, you could see 11.2.5. That's what the solution templates came with. But obviously, we will add more versions part of the drop-down menu. And the options that you see part of the Bootstrap, you have an option to select either if you want the default configuration to be in place. We will pretty much have the policy configuration, etc., whatever you need for your outbound and east-west protection, or if you would want to provide any bootstrapping parameters. So this is the place where you also provide our licensing information if you selected the BYOL licensing model, where you can enter the device certificate pin, device certificate value, which are needed for the licensing, which are fetched from our customer support portal. So you can provide pretty much any of the bootstrapping parameters which would bootstrap with your deployment of your firewalls.
Got it. So how, so because we selected, what was the option? Bundle,
Mhm.
we have to pick this one.
So that option, Nihali, would give the users the default configuration. So the users need not worry about any configuration on the firewall. So once they have the firewall deployed, they just need to configure the UDR and point the traffic to the front end IP of the load balancer, and your outbound and east-west traffic will all get inspected. The other bootstrapping parameters with the other options are, for example, if the customers has any panorama, which they have in their environment, they can also provide the panorama IP, device group, all the panorama related information. And you also see there is a VM auth key and pretty much all the information, licensing information as well, which can be provided. But since this is a pay-as-you-go service, the licensing is already taken care of under the hood. So you can select the default configuration, which should pretty much bring up your firewalls with the default configuration. Yeah, that's it. We can click on review and create. That would pretty much create our entire deployment resources for us.
Yeah, so we have been using the BYOL, Bala.
Okay. Oh, I see. Gotcha. Oh, I see. With this particular, oh, I see. Purchase due to validate cannot be purchased. Okay, I see. There might be a policy which would not be allowing the purchasing of the bundle one. That's okay. We can go back and change that to BYL and then have that deployment.
So yeah, so one of the questions I had about BYOL, I'll kick off let's kick off the installation and we can talk about that, is that I, when we labbed it earlier, Daniel and I labbed it earlier, we were able to use it, and I'm not sure if we entered the license anywhere. So that was the other question.
That's a very good question, Nehali. So you can enter the license in two ways. First is you can provide that part of the bootstrapping parameters. So part of Palo Alto Networks, like in the website, we can also show how a sample bootstrap file would look like and how they can include the parameters. So we can include that file part of a bootstrapping. Or the other way, if the licensing information is not provided part of the bootstrap, the other way is once your firewall is deployed, up and running, you can log into the firewall manually, and there is a section on the firewall UI where you can enter the licensing information. And I can show that as well once this deployment is completed.
Once we deploy it, you could show it to us in our lab firewall. I think that would help us better,
Yeah,
if that's okay.
absolutely. Absolutely.
Okay.
And as we can see here on our screen, we have started our deployment. And one important thing to kind of like note is we can see all the resources that are required to have our security VNet deployed, have all the resources up and running, including the IP configuration on the firewalls and the load balancers. Everything would be taken care of by the solution template so that the user doesn't have to worry about anything.
Yep. Yeah, so what we'll do is once it deploys, we'll take a look at, make observations about all the different resources. Yeah, so one of the things that we want to do is we want to do an architecture overview and envisioning while this deploys, and then we'll go back and look at it in the Azure portal as well as on the Palo Alto side.
Yep.
So while we wait, what we just triggered is it's going to trigger a Palo Alto sandwich design. Like Bala mentioned earlier, it's going to deploy all of these resources, two firewalls, load balancers, public, private, and management networks, and in a highly available configuration. We paused the video and now the deployment is complete. So let's go and look at the resource group to see what all it deployed. Let me sort this by type and then we'll go and walk through the interesting or important resources. So it has 2 pages. So let's look at the first thing that we will look at is the VNet, and then we'll make some observations on the 2 VMs, the firewall VMs that got provisioned. So let's start with the firewall VNet. Go to settings, address space. Here it deployed a /16 for us, and it created 3 subnets: management, public, private. Notice the third octet 0, 1, and 2. And then if we go look at going back to the resource group, let's make a few quick observations. Okay, so now we looked at the VNet. Let's go make some observations on the VM. So for the VM, if we go to the first overview screen, you can see that there are 3 associated public IPs over here, and you could see that it has a management interface, untrust interface, and then there is also an LB ingress. But let's look at first all of the interfaces. So I'll go into the network settings, and you can see that we have the uh, management, untrust, and trust. So let's make observations and grab all the IPs for the management interface, these 2, and we'll update the diagram. And then we'll look at the untrust. Untrust also has a public IP and a private IP. And lastly, we'll look at the trust. Likewise, the trust does not have a public IP, but it only has a private IP. And then we'll go into the second firewall. Were we on the first one or the second one? I forget.
I think you were on the first. You were also in the first one.
The VM one, right? Okay, so
Yes.
now we make, thanks Daniel. Yeah, so we make the same observation on this one, management, public and private on VM2, and then untrust, public and private. And likewise, we will look at the trust one, private IP. So we'll grab all of these IPs and we will update the network diagram. Anything you want to see in these 2, we can then go into the load balancer next.
Yeah, it's just observation that I saw where while you browsing the interfaces, there's an NSG associated, right, to each one of the interfaces.
Yes.
And one is they trusted and untrusted. They have NSG all, allowing all traffic, which makes totally sense, right?
Yes.
Because this is a file.
Yes, exactly. Good point. Good call out. Yeah, so the public has allow all and private has allow all, and management has its own NSG. So let's take a quick look. For now, it does say allow all on all of them, but of course we want to make sure that management is also allow all. That's how it comes out of the box. Yeah, good point. Anything else? And then we saw the three public IPs over here. So one is on the untrust management, and we'll be looking at the LB ingress IPs next. So going by, we've sorted this by type. So there's a couple different public IPs associated with it. And then let's go back and see what else. So we looked at the NSGs, and these are all the interfaces, different interfaces on different subnets. And so now let's look at these 2 load balancer. So out of the box, it also provisions 2 load balancers. So here we have 2 load balancers. The way they are named is the ingress one is the public facing one, and it would have a front end public IP, and it has a backend pool that goes to the untrust interface of the firewall. Okay, and if we look at the load balancing rule, it allows port 80 in, and if you look at view details, it shows that both the firewalls are behind the load balancer. Anything else, Daniel, on the LB ingress? This is the public facing load balancer in the sandwich design.
Yeah, Nehalis, if you go back to the just the other details of the load balancer rule, I think you just check the The back. Oh, you're checking now the load balancer rule. My apologies. We're checking first the back ends, right?
Yes, so let's check
Okay.
this. So this is the front end. So let's go check the back end. The way it is labeled is it's LB egress. So yes, so this is the back end, and the front end IP for this one is, we note this down because this would be useful in the UDR. And if you want to look at the backend pools, they are hitting the trust interface of the firewall.
Which makes sense because the IP also on that front end IP belongs to the same subnet, right?
Yes, exactly. The 2.100. Yes,
Gotcha.
exactly.
Yep.
Yeah, and then in the load balancing rule, we would see that HA ports is enabled on the egress, so the internal load balancer, the HA ports is enabled. So we're allowing all ports.
Makes sense.
Right, and then likewise, if we make an observation on the ingress load balancing rule, out of the box, floating IP is not enabled, and we'll go into depth a little bit later on that one as well. So just capturing all the screens. Anything else, Daniel, over here? Let me check my notes.
I believe the session persistence. I don't know if you want to just talk a little bit, or you're going to talk about later on that.
It's a good point. Let's
balance.
make
Yeah.
an observation about it. So out of the box on the ingress load balancer, so the public facing load balancer, it's set to source IP and protocol by default. And this will, like Daniel mentioned, will come into play in a little bit, and we'll go deeper then. But let's just see what the default settings are. We can capture those screens. So yeah, on this one, the internal load balancer, the persistence is set to none.
Correct. Which means it's going to do the 5 triple hashing and evenly
distribute the
distributed the traffic across the interfaces of the trusted interfaces of each file.
Exactly. Yeah. So far what we did, and jumping back into the architecture, so far what we did is, when we kicked off the script, it deployed the 2 firewalls and the public-private management networks, the ingress LB, and then the egress LB. Okay, and just for completeness, I'll just drop all the IPs in here, so when you follow along with us, you can see which IPs, which firewall we are on. Okay, so firewall 1 is management is in yellow, and firewall 2 management is in yellow. So with that, let's start to look at flows, Daniel. Maybe we start with, everything would be from the perspective of this VM, and we can set it up so that we can observe the outbound flows. So initiated from this VM, and how do we make this flow going out to the internet? And in this first scenario, we will use the instance level IP, right? So anything else you want to call out in this? We will then lab this one.
No, I think that's very clear. Instance level, which means each file has its own public IP, and the traffic is going to go out to the internet on each instance, right?
Yes, outbound. Yeah. So what we will do is we'll set it up on the Palo Alto side, and then we will jump on this VM and we'll run our tests. All right. So let's go see how, we'll make some observations first on the Palo Alto side. So out of the box, we are now here. We can hit it, the admin portal using the management IP, and this is what it looks like. And then this is the second firewall. They're both labeled FW1, and this is one of the questions I think we'll save for when the Palo Alto team joins us. Daniel, because they're both named named Firewall 1, so it shows up as
Because of
Firewall
the
1.
first name. Interesting.
Yeah. So I did observe that. Yeah, so let's take a quick look at all of the networking related items here. So we'll start with interfaces. So the untrust is 1-1, trust is 1-2, and it's also labeled in the diagram. And another observation here is that this NIC is DHCP. I would say that from best practice, Daniel, I would say maybe on the Azure side, set it
Only
to
correct.
yeah.
Only on the Azure side, because technically any VMs in Azure, they
Yes.
are DHCP client.
Mhm.
So yeah, at the OS level, always VMs in Azure
DHCP.
DHCP client. However, when you go over the interface in Azure, you need to make sure that IP is also static.
Yes, so that was the observation. So for best practice, once you deploy it, be sure to go in here and make it static. But like Daniel mentioned, at the OS level, they would still be DHCP.
Yeah, and just to add that, so why you need to do that? Because if you shut down one and deallocate one of those instances, technically for Azure, that IP is going to be available to get allocated if it is set as dynamic. And if you deploy a new VM in the same subnet, that IP can be associated to that new VM. So in order to avoid that potential assignment of that IP is always recommended to, and obviously this is a firewall, and you want to make as predictable as possible, and make it sure you change in the interface of in the Azure portal to static.
Yeah, good point there. And then another observation is, IP forwarding is also enabled on the NIC, and we would see that same thing on the untrust side as well. That IP forwarding is enabled, and be sure to make the untrust side static as well. Yes, so coming back to the observations here, so we started with interfaces in Palo Alto's. There are two zones, untrust and trust. Notice one belongs to untrust 1-1 and 1-2 belongs to trust. And then we'll look at the VRs, the virtual routers, trust and untrust. Okay. So this is all out of the box configured. And another thing I wanted to show you here is, in addition to the networking interfaces, there are two important constructs for their policies. So there's security policy and then NAT policy. So out of the default setting is that outbound NAT, SNAT is enabled. So remember this VM, this flow, it will egress using these two public IPs by the virtue of this NAT rule. Okay. And for security policies, we don't have a policy that allows this traffic. So we will have to add the security policy. Anything else you want to see in here? We looked at the network tab, we looked at the policies, the NAT, oh, and the monitor. So here is where we could this is useful for troubleshooting. We can capture packets.
Nehali, on the, in order to, you need also NAT rule, right? To policy to make sure when you send it out in our first flow, the traffic outbound with the instance level IP, you have to define that as well, correct?
So I noticed that out of the box, if we go under policies, this NAT policy, outbound NAT SO, is already configured. So we
Oh,
don't need to
okay.
do it. And I see that it's configured on both.
Oh, got it.
Let's see. I just want to make sure it's configured on both. Yeah, so we have this, looks like ready to go. So we can, all we now need is to steer the traffic from spoke to the firewall, sorry, the internal load balancer. So we need to add this UDR pointing to the internal load balancer IP. So it would be the 172.19.2.100. So let's do that then. So here on the spoke, let me open the spoke VM here. So we'll start at the overview page. The spoke VM is in this subnet. I can't remember if I peered it. Yeah, so let's peer it with the, first with the, just going back to the drawing board here. We'll first peer it and then we will add the UDR. Okay. And so let's create a peering to the hub VNet. So we will pick the, not the hub VNet, but in this case, it's the firewall VNet. So we'll call it peering. Right. And here we will call it peering to. Anything else? Do we want to check this box?
I think we're
And
good.
yeah, okay. So that's the peering, and then let's go ahead and start to create a route table. I think I may have a stub route table, which I don't have a route table, so let's go ahead and create one. So we'll call it, we'll put it in the same resource group, East US. Just want to make sure that it is East US. Yeah. And we'll call this route via pan FW. Next, and we'll review and create. Let's see how our peering is looking. Looks like it's established. Okay, so we now have the route table here, and we will add a route. So we'll say default route. And here we will type,
The load balance IP.
right, 172.19.2.100, right?
Yep.
And before I associate the subnet, I wanted to show you that this VM that I am on, the VM I showed you in the diagram, if I do curl ifconfig.me right now, it is egressing using this 238.79 IP, the last two octets being 238.79, and then after we steer the traffic through the load balancer and the firewall sandwich design, we'll see different IPs over here. Okay, anything else you want to capture? 10.10.10.114 is the VM IP. So I think we're ready to associate the subnet. Oh, and I think let's capture the effective routes as well. So default is still going through the internet, and this is the effective routes on the spoke one, and it's going through the internet. And so once we associate the subnet, it will then go through the load balancer. Okay, and here we have this, and we still haven't configured any security policies. So I think this, I expect this to fail as soon as the routes kick in here. Okay, so now the default gateway is through the load balancer, and this should expect this to fail until we fix the policy, Daniel. I think we have to go in and update the policy, but we should be able to see traffic from I think that traffic would be dropped. So let's go and create a policy here. So we'll create a security policy to allow the traffic. And for now, again, this is not a best practice, but we'll just do an allow any rule to make sure all traffic is allowed. So we'll just go and any source, destination, any application, any. And here in Palo Alto, it is important that if you check this box, it would also show, it would also log at the start of the session. So it's useful for troubleshooting. So we'll go ahead and hit save here and then commit. Now, we will have to make this change on both the firewalls because they are active from Azure perspective. So we will go and add the security policy here as well.
Is there any way to sync those policies, or from the Palo Alto perspective, it's Panorama would be the...
Yeah, that's a great question, Daniel. Yeah, so what I think you bring up a good point. What we can do right now is we add it in both places. And when we meet with Palo, we would work with them to make it best practice.
Right.
But what I can tell is that if you go to, let me go ahead and commit and then we can talk through that. So it takes a few minutes to commit. So one of the things that I observed was that if you look at this device and high availability, the config sync is set, is checked, but it's not syncing the config because I believe, like you said, it may have to be done through Palo and also enable this HA for it to sync the config. But until we meet Palo, we just go through, we'll add it in both places. So at least we can talk through the whole sandwich design and how the traffic is flowing. And then we'll look at the HA bits with the Palo Alto team. Okay, so the policy is now allowing. So let's go and check to see how it looks. Okay, so we got 246. Is that one of the IPs? And 125. Are those the two IPs on the untrust interface on the firewall? So 140.125 and 140.256. So going back to our diagram, if I light up the IPs, 140.125 and 140.256, 246. So it is indeed working. VMs, and we will see the same IPs, which we captured before, 140.125 and 140.246. Yeah, so it's cycling between the two.
Which makes sense, right? It's cycling because it's using the evenly, right? Load balancing. on the session persistence is set to none.
So we just looked at this outbound flow following the default route, hitting the load balancer. Load balancer can pick either of these two. It will get SNATed over here, as we saw in the NAT policy, and then the return traffic will come in. Here the green line is the return traffic, and then this will bypass the load balancer. This flow right from the firewall to the VM will bypass the load balancer. Let's take a packet capture on this VM to see what the return traffic and the end-to-end capture looks like. So we'll jump on this VM and run the same curl command again, except that we'll run it with a packet capture. Okay.
Makes sense.
All right, so here I am. I have two windows open. I am on that spoke VM 10.1.1.4, and we will run, first let's run an ns lookup of ifconfig.me. So it resolves to 34.160 IP, and let's run a packet capture with that host. Okay, and then when we run curl ifconfig.me, as you can see that it goes, the source is this, destination is ifconfig.me, IP of that, and the return traffic is also coming from the original source. And so coming back to the drawing board, this bypasses the firewall, bypasses the load balancer, and we see the original source IP. Anything else you want to comment here, Daniel, on this return traffic?
No, it makes sense because in this case, the instance level IP creates the symmetry, right? Between
Exactly.
on the response.
Yeah, so this NAT will ensure that the return traffic comes back here, and from here it will follow this peer, like it knows about the 10.1 network through this peering.
Correct. And because we only have one load balancer and one instance involved, because of the instance level IP, right? The symmetry is always kept in this case, because we can
Exactly.
ask why I'm sending like for the public IP, right? Why doesn't switch to the other one? It doesn't switch because the load balancer knows already that the traffic is coming back from the same instance. Okay, just a quick recap regarding the outbound flow, where we have the spoke 1 VM, Azure 10.1.1.4. As you can see, we have a side-side networking capture on the top, where we take the network capture on that spoke VM. And at this bottom screen, we do access ifconfig.me. If you take a look when we resolve the DNS of ifconfig.me, we get the public IP 34.160.111.145. And what's going to happen is once this is resolved, the connection is going to initiate from the spoke 1 VM towards the default route, which in this case is pointing to the internal load balancer, the LB egress. When it hits that load balancer, the load balancer is going to pick one of the instances, which in the demonstration he is picking the FW2, the firewall2 instance, and the firewall2 instance is going to forward that connection towards to the internet. As we reach out the ifconfig.me, the return traffic, it's going to go back through the green flow. And as you see, and is highlighted over the networking capture, the blue flow, we see obviously the target IP 34.160.111.145, which is highlighted the sync package on the blue highlight, while the return traffic, which is the SNAT, is the return traffic which reflects the green flow on the left, which means when the traffic is returning, we don't go through the load balancer again, which means the firewall2 is going to connect directly, send that packet directly to the spoke one Azure VM. And if you check the subsequent connections, it's going to happen the same thing. And if my ACK, the third one, which is leaves, it's highlighted in blue, it's going to go over the blue flow, which means it's going to go over the load balancer. Load balancer knows already that I opened that flow, that conversation with the firewall true. It's going to keep that symmetry with the firewall true. And because we haven't changed anything from source to destination port, which means we're going to keep the same 5 tuple here towards the firewall true, and the same idea applies. So seeing ACK, we do have anything that leaves the VM going towards the public IP of the config of me. The blue flow goes over the load balancer, while the return traffic that's coming back towards the firewall true goes from the firewall true straight to the Azure VM. Does that make sense, Nehali?
Yeah, definitely. Thanks for elaborating on that one, Daniel. So to summarize, traffic initiated from this VM would follow the default route to this LB. It can pick either of the firewall. In this picture, it picked this one, and then it will get SNATed out to the internet. The return traffic, because of this SNAT, will land on the same firewall. And from this firewall to this VM, it will bypass the load balancer. Okay, and likewise, again, this will be dependent on the 5 tuple hash. So for that same flow, it will always go to this firewall, right, Daniel? So that's the
correct.
key. And so, all right, so with that, I think that's the instance level. Unless there is anything else, we can test out here the NAT. So let's now test the NAT gateway, Daniel, here. So what we will do is we'll associate this outside the untrust subnet or the public subnet with the NAT gateway, and then we should see it egressing using this IP. So it takes a few seconds, so let's go ahead and turn on the NAT gateway. Oh, I don't have a NAT gateway deployed. It does take a little while. We'll kick it off and come back and revisit. So looks like this one is now deployed. So let's go ahead and associate it with our subnet. So the public subnet, and we'll say save. And we still have our curl command running here. And we'll go ahead and hit save here.
And the observation here is every time there was associates a NAT gateway to a subnet, it's going to override the instance level public IP, right?
Yes, it takes precedence over the instance level public IP. So the instance level is still there, but it will not use that. It will instead use this public IP, and it will always be one IP. Or if you have a prefix list, it could be multiple.
Correct.
And this may take a few minutes to kick in. Let's give it a go. It does take a few minutes to kick in. What was the IP again? 195.3. Let me get that IP. I'll update my diagram. I think my diagram has an older IP for the NAT gateway. Let's try it again. Oh, there it changed. So now we can see that it became 195.3, which is the NAT gateway IP that I just put in. So hiding the IP to unclutter, it is going through this. So I think, Daniel, this is a good point to talk about why we would use NAT gateway versus there's another option of using egressing using the LB as well. So we can have an SNAT over here, and then we can have an outbound rule on the LB and egress it that way as well. So there are three really options, but maybe we talk a little bit about the pros and cons of these three options.
Yeah, the biggest decision point is going to be related to the SNAT port allocation. So in the case of the instance level, for each instance, we're going to have like technically a good room for SNAT ports. But when you move to the load balancer, one of the, I would say, disadvantages is you can technically use the external load balancer as with the outbound rule, and you need to set the outbound rule. You can specify the amount of source NAT ports, which you can technically add multiple public IPs, but the only point is you have to set that manually, the amount of source NAT ports, which is not really dynamic comparing to the gateway load balancer. We do that SNAT port allocation dynamically. So which means if you have a scenarios like VM scale set, for example, in a scenario with the load balancer, we need to revisit the outbound rule and redistribute the SNAT ports in the outbound rule. While in the NAT gateway scenario, you don't need to do that because our platform is going to do that distribution of the SNAT ports dynamically for the instances that you add behind the NAT gateway.
Yeah, so this option is the sort of the most scalable, more deterministic option for
Correct.
outbound.
Correct. So our recommendation, if you have a lot of applications making outbound calls, the Microsoft recommendation is to leverage the NAT gateway.
Excellent. Thanks, Daniel. Yeah, and just for completeness, for the load balancer, the flow would be very similar. It will follow the animated flow is the one that's initiated by this user, and it will follow the default route to the load balancer. Pick one firewall, will get SNATed twice at the firewall level and also at the load balancer level. And then the return traffic is the non-animated orange line in this case. And from this VM to the Azure VM, it will bypass the load balancer. Right? Anything you want to add there, Daniel?
Nope.
Perfect.
That's correct.
Perfect. So now I think we're ready to do the inbound flows. So from the perspective of this user initiated from outside, coming into the load balancer, it will pick one of the firewalls. It will get SNATed over here. It will, again, this blue flow bypasses the load balancer, and then the return traffic will then go back to the firewall. And if we didn't SNAT, this is the key point for this flow, that if we missed doing the SNAT over here, the return traffic will get there is a potential for it to get asymmetric because it would follow the default route, and its entire possibility that it will pick the wrong firewall, right? So this is where the SNAT becomes important in this this flow.
That's correct, Nahali. So if you have just a single firewall, it would work without the SNAT, but when you have multiple firewalls, you are required in order to have traffic symmetry that SNAT at the firewall instance level.
Mm-hmm.
And the main reason why we need to enable that is because without that SNAT, the internal load balancer doesn't know where the flow is coming from. And because they are two different entities, the external load balancer and the internal load balancer, so they don't exchange the flows between them. So that's why you're required to do the SNAT at the instance level in order to work properly in this scenario.
Exactly right. Yes. And so this flow has no idea, like it is not going through this load balancer. And this load balancer and this load balancer are distinct. They are not aware of each other's flows. Perfect. Yeah, so at this point, I think we're ready to lab this. And so now let's go ahead in the portal, in the admin portal for the firewall and set up the DNAT rule. And then we'll initiate some traffic from outside and make sure that we can hit this VM. We may have to run a small web server over here, Daniel, just to kind of see it work end to end. So let's go ahead and set up the DNAT.
Okay, question, Holly. If you go back to the diagram, your
Yes.
load balancer already has the rule to forward the request, right? Just this observation.
Oh, yes,
From the
yes.
file.
Let's double check that. Yeah, so load balancer is already sending. It's a good point. So let's go look at load balancers. It's the ingress one, the public one. So if we look at the rule, yes, right now it already has 80 being forwarded to the two firewalls.
And that comes with the template as well, or did you
Yes.
create admin comes
No,
with the
it
template?
comes with the template. Yeah.
Okay, makes sense.
So yeah, they're both up. So like how we did it with the security policies, when we set up the DNAT, we would have to set it up on both the firewalls. So let's go ahead and set up the DNAT. And so here we'll go into policies, NAT, and we will call it DNAT to VM, original packet. So this is the key. Here we put the IP address of the untrust interface of the firewall. So in this case, it's going to be 172.19.1.5. So this is the first firewall. So original packet untrust service HTTP, and this is the untrust interface IP of the firewall, and then the translated packet would be, we'll use the interface IP, which is the trust interface, and we'll call this static, and we'll map it to 10.1.1.4, which is our VM. We'll run a web server on that VM. And let's see if we're missing something here. Okay, so let's walk through this again. So we'll create a NAT policy rule. For the original packet, we'll use the source of untrust, the destination zone as untrust, destination interface as any, and then the service HTTP. And the most important setting on this one is the this destination address on the original packet is the untrust interface of the firewall, and then the translated packet we would use the interface IP as, I'm sorry, interface address, and this is the trust interface. And the destination would be our VM 10.1.1.4, and we'll have something listen on that. So let's go ahead and hit OK here. And it takes some time, so we'll go ahead and hit commit here. And likewise, we'll mimic the rule on the other firewall. Okay, so let's set up the NAT on the second firewall, and we'll call this DNAT to VM, IPv4, original packet. We'll add the zone as untrust, the test in the original packet, and we'll just make it service HTTP. And here, this again is the important part. This is the untrust interface of the second firewall. So 172.19.1.4. Oops. And then the translated packet. This is the trust interface of the firewall, and we'll call it static, and we'll map it to 10.1.1.4. Okay, and again, the service is HTTP, so port 80, and we'll hit commit. And let's go ahead and get our VM ready over here while we wait. So here on the VM, we'll make it listen on port 80. So we'll call it so now it's listening on port 80. So let's make sure this is done, and let's grab the public IP of the load balancer. And this is where, Daniel, I was using your script. So maybe we could use that. So we'll first just hit it just normally. Okay, so we got a 200 OK over here. And if we go back and look at the VM, yeah, sure enough, we are seeing that. So let me do this. I'll hit it a couple of times, and we can watch this simultaneously. Okay, so here we can see that it's going to the first firewall, and it's always going to that firewall. So this is where first time, I think, Daniel, you and I did this lab. We observed this and we went down the troubleshooting path. If you want to talk about that journey.
Correct. If you recall at the beginning when we reviewed the external load balance, the LB ingress, we saw that configuration, the LB rule related to the persistence of the rule, right? Session persistence.
Yeah, so
and
let's
I believe
go there.
And let's take a look there. And I think that is going to show us the explanation why it's having this behavior. Yeah, if you take a look on the session persistence, yeah, we do have those three options. And by default, when you deploy this template from Palo Alto, the LB ingress, the external load balancer, it defaults to the source IP in protocol, and that's why we're persisting always to the same instance, correct, Nahali?
Exactly. Yeah. So we always got 172.19.2.5, which according to our diagram is the first firewall, and we're always getting that. So let's toggle this and then run the test. Yep. So we'll save this. And we also tried a couple different commands, so I've listed them over here, Daniel. I think you gave me this command in case you want to kind of make sure that it doesn't keep the same session.
Yeah, yeah. Usually HTTP requests they do have keep alives, which they try to reuse the same socket, which may not trigger the load balancer to do the 5-tuple hashing, and that's why we have these extra parameters to make sure we disable the keep alive, and every time that we issuing this invoke web request, it always opens a different source port, which is going to trigger the load balancer at this point, which doesn't have the session persistence because we disabled. And what's going to happen now is going to take a look on the 5-tuple, and any one of those components of the 5-tuple changes, source destination, source IP, destination IP, and port. Any one of those they change is going to trigger the load balancer to send the request evenly to the other instance.
Right. But even with this command, it wasn't working because our load
Yes.
balancer
Yes.
had the, so now let's see how it looks. And now if we issue this command, it should cycle between the two firewall. As you can see, it's cycling between the two. So perfect. So let's analyze this flow one more time. Inbound initiated by this user hits the LB. We set up the DNAT on both the firewalls. It gets SNATed by how you saw the IP. If I light up the IPs again, we saw 2.4 and 2.5 and 2.4. And then, of course, the return traffic bypasses the load balancer because it knows it goes to this IP and then back to this LB, back to the user. Any other comment on this flow before? I think our next layer is the floating IP kind of deep dive, but anything else here?
No, I think it's we covered what we needed and uncover few caveats that we need to take into consideration when implementing the solution related to the load balance and session persistence. And like I said, I think the next one would be the related to the floating IP aspect.
Perfect. And I'll make a note of just bringing that to Palo Alto's attention, the default setting for the load balancer that as well. So we can discuss that in our session with them a little bit later in the video. Perfect. So this sets it up for floating IP concept, but let's look at the default behavior, what we just tested. So let's look at this behavior out of the box without the floating IP enabled. What happens is we hit the public IP of the load balancer on 80. It goes to the two untrust IPs on the firewall on port 80. But imagine that you had a second front-end IP. So this is public IP1, this is public IP2. What would happen? In that case, our load balancer wouldn't allow us to use the same port. So there are two techniques, right? So the first technique is what we call, we can't reuse the port, so we will use a different port. So that's the first technique. So you would then send it to port 81 on the firewall, but imagine the operational overhead, right? So this is without, we're still not using the floating IP. So this is before the floating IP, it goes to the backend port 80 and 80. And so now I tried to put all of this in one picture here, Daniel, so we could visualize it a little better. So with floating IP, it makes it a little better because this is not scalable, right? Like you would have to do a lot of ports on the firewall. So with floating IP, what will happen is uh, if you hit FIP1 on port 80 over here, it will send it to the backend on FIP1, the front end IP1 on port 80. If you want to elaborate a little bit over here, Daniel, I do have a layer here. So if you want to, because this is a very important concept, I thought we take this opportunity to explain the before floating IP, after floating IP, and the two solutions, that I have listed over here. I kind of explained it in our context, but this explains it in a generic sort of context.
Correct. Yeah, I think the main benefit here is, I mean, without the floating IP, you have the overhead of exposing when you have multiple front-end ports. So the main goal here, okay, I have multiple front-end IPs that I can add in my load balancer. And obviously, this is not really scalable, like Nehali has mentioned, because without floating IP, every time that you add an extra front-end IP on the load balancer, you have to tweak on the back end a different port in order to work properly. So, which means it's not scalable. It adds a lot of administrative overhead to keep tracking of those ports on both sides, right? In the load balancer rules as well as in the firewall. With the floating IP, what we do is we create the consistency of keeping the same port, reusing the same port as a front end IP, as well as when the load balancer forwards that request to the back end, it keeps the same port, which means I don't have that inconsistency that we see on the solution one without floating IP. Now we have consistency because we're going to keep the same ports in the front, in the load balance rule, uh, as well as in the firewall, which keeps consistency across. The only caveat here, as Nehali is going to explain on the firewall configuration, we need to tweak also in order when you switch the floating IP in terms of traffic, the behavior changes, right? Because in the solution one, what happens is from the load balancer perspective, without the floating IP, remember that you're going to, if you recall, when we define the NAT rule, we define the untrusted IP of the firewall instance on on that DNAT rule, which in the floating IP we have to change that to the IP of the front end. So that's the caveat here when you're building the rules on the file that you need to account is we are not going to point anymore for the instance untrusted IP of the file. Now we're going to use the same front end IP that you use in a load balancer. You're going to add that to your DNAT rule.
Exactly, yeah, and we'll demo that, right? We'll
Yep,
lab,
we
we'll
found that.
we'll show
Yep.
that. Yeah, perfect. Yeah. So I think with that, let's yeah, this is the fun part of this. This is the advanced scenario of the demo. So we go into these firewalls, and like Daniel mentioned, we'll clone the original rule, except that we'll flip the, instead of backend IP, we'll use the front end IP. So we would also need to create the rule on the load balancer and add a few more public IPs on the load balancer before we do that, right? So let's add two front-end IPs. And we'll say save, and we'll add another one. Okay, let's refresh this. So now we have two front-end IPs, and in terms of the load balancing rule, we'll create two rules. We'll call this we'll pick FIP1, we'll pick the same backend pool, and we'll say 80, and we'll say 80. And we'll pick the probe. So now what will happen is I'm intentionally going to make it fail. Floating IP is not enabled. So when I try to hit save over here, it will fail. And this is the key concept, right, Daniel?
Correct. Which in that case, we would need to change that backend port to another port, which would be back on the diagram, the 81, and that
Yes.
would commit. But our goal here is to apply the best practice, right, Nahali, which is
Yes.
keep 80-80 consistent, and we're going to move forward with the floating IP.
Exactly.
Option
Yeah.
checked.
Yeah, so we could do 81, but that would be solution number 1, but we're going to check the floating IP. And the thing is, Daniel, we can't just check it here. I have to first check it on the one that existing one and then come back here.
That's
So
a good
let's
call, because you need to move the existing one to floating IP before you enable on the new one.
Yeah.
Good call, Nahali.
So I intentionally left it kind of going. So here we would just go and do FIP1, backend pool, 80, 80, and we can have, now it will allow us to do floating IP and save. So there's configuration required on both Azure side and the Palo Alto side. So let's start with the Azure side. We'll get it all ready. So we'll pick the second one. So now we can pick 80. Perfect. So once this is set up, well, let's refresh all the rules here, and we have both the rules set up. Let's go ahead and set up the DNAT on the Palo Alto side. So here we could make this a little bit easy. Daniel mentioned this earlier, but the biggest focus here is that this, which was the untrust interface, will now change to FIP1 and FIP2. So let's go ahead and clone this, and we'll call it OK, and we'll rename this to FIP1 DNAT. And the biggest thing here is that this will now become the FIP1. So let's grab FIP1 from here. Keep me honest here, Daniel. I am going to be making typos. And then we'll clone this. We'll again clone this.
And it's going to be the front end IP. 2.
Yeah, so we'll call this. And then here in the original packet, we're going to put
front end IP 2.
So we got this, and you could see that the only difference between these two policies is that it has changed, that it's going to have the FIP 1 and 2 here.
And
So
technically, Nehali, the original one, you would need also to change to the front-end IP, right? Technically, in order to work properly, correct?
Actually, absolutely right. Yes.
Yeah.
Uh,
So
yeah,
we would
yeah,
need to
and
get the
it will
front-end
fail.
IP.
We can
Yeah.
show that the original, yeah, good point.
You fail.
Yes,
You fail,
it
right?
will fail. It will fail, and we can then add the original IP. Yeah, great point. And so we need to mimic these two on the other firewall for completeness. So we'll go ahead and quickly do that. So I'll quickly clone this too. And we'll go ahead and commit. And while we're waiting, Daniel, let's stage our commands because my IPs may be from the older lab. So I have staged this here for us. So we'll be using FIP1 here. And let's grab FIP2. And we will see that our original one will fail. Yeah, original one stopped working over here, right?
That's correct, because we
Yeah,
haven't changed the
yeah, yeah,
backend
yeah,
IP
yeah,
to the front-end IP.
yeah. And yeah, so one call out, I think, Daniel, you and I had done this with other firewalls and Linux VMs instead of Palo Altos. And our official documentation sort of calls out for loopback, right? So maybe we can talk a little bit about that. So, you know, instead of just setting up the NAT, there are other ways to do it. You could set up loopback interfaces with those IPs as well.
That's correct. Our documentation usually, actually, our documentation recommends customers to add a loopback IP in order to make this to work properly. But because we're talking about files over here, we don't need to add that loopback IP because the file is going to review all the packets from all the layers, right? It's going to be able to extract that front-end IP, and the DNAT rule is going to be able to process it correctly as we. So we don't need to add on the file scenario the loopback interface to work
Exactly,
properly.
precisely. Yeah, thanks, Daniel. Yeah, so looks like we have both of the DNAT set up. Should we give it a go?
Yep.
Okay,
Let's try.
so okay, all right. So here, first try it works, and maybe we can look at the this one side by
The
side.
source
Uh,
port, yeah.
yeah, so let's see if I
Oh, the
can
source
have.
IP of the
Looks
instance.
like this one has the session has timed out. We'll have this side by side. Let's try this again, and we'll try it again. So that's cycling
Nicely.
through. Yeah, and then this is front end IP2. Nice going. And then the original one will break. To fix the original one, all that we need to do is just change this to the original front end IP.
Yep.
This one. And that would fix it. I do want to make an observation at the packet level, Daniel, just for the completeness of the recording, is that in the capture, you will see that the destination of the packet is the public IP, right? So if we just look at this destination, these two are the FIP1 and FIP2.
Yep. Good observation, Nehali.
Perfect. Yeah, and just this tool in Palo Alto is very useful. When we were originally labbing it, first time we labbed it, Daniel, we used this a lot, and for the demo we kind of didn't have the need to do it. But anytime you run into any issue, this is my go-to kind of tool. And then you can also click on. It's very nicely done. So if you just click on it, it kind of gives you that uh, filter, and then you can just filter based on those. So I just generated some traffic so we could look at the logs here. And if we look at this packet, for example, over here, we'll look at this one. This looks like a complete one. So if we look at that one, here, you could see that if you click on this icon over here, the magnifying lens, it tells you the full story, that it got natted out to the 10114, also gives you that all interface IP, the zone and everything. So it gives you the full kind of packet view. So very useful. I do have a snippet of it in case you were using this draw.io. I have saved the original one, which was hitting the outside interface, but we could grab it for the FIP1 and FIP2 as well. Any other observations here, Daniel, in the packet capture that you want to make?
No, just a comment. Very nice and friendly view in order to uncover and troubleshooting when you face issues.
Yeah, absolutely. So I think I'm just going to go over my notes here to make sure we covered everything. So Daniel, I think we are almost towards the tail end of this presentation. Maybe we cover the last few flows, which are sort of east-west. We don't have a lab for it, but we kind of, for completeness, we show the east-west flow. So from on-prem to Azure and from Azure to on-prem.
Makes sense, Hannah. Yep.
Yes, so let's look at that. And again, we will look at it from the first flow, we'll look at it from the perspective of this VM, so initiated by this VM. So we'll call it Azure to on-prem. So again, the animated flow is the one initiating. So let's follow this flow. So the first leg is UDR to ILB. And keep me honest here, Daniel. ILB will pick one of this.
Yep.
This flow will bypass the load balancer, return traffic. I think this flow needs to be a little bit here, right? The
It goes back
return,
to the express route gateway. Yep.
yeah. And then gateway subnet UDR to the ILB. Let's make it.
Mm-hmm.
And this is the key, that this ILB is going to pick the same firewall because of the 5 tuple.
Yep. Because we're hitting the same load balancer in the way out and the way back, right?
Mm-hmm.
And the considerations here, as Nehalia has pointed out, is uh, we need like a UDR on the gateway subnet.
Mm-hmm.
One observation that UDR for the gateway subnet, you need to make sure you add the as a destination the whole virtual network of the spoke one, which is 10.1.0.0.16. It doesn't work if you just add the subnet of the VM. You have to use the whole virtual network address space in order to work properly.
Good
And
point.
and there is a second observation, Nehali. When you create that UDR on the spoke, if you remember and if you go to the portal, there is a property on that UDR talking about the
Ooh.
gateway.
Good point. Yes. Yeah. Yeah.
Gateway propagation to the route table where you created and associated with the spoke VM1.
Yeah. Yeah.
So another important is when you go to the configuration here, one thing when you have any type of gateway involved in the traffic flow, which in our explanation, we have express route gateway or VPN gateway, you need to make sure this propagate gateway route is set to null, because if you don't do that, the VM is, instead of sending the traffic to the load balancer, is going to send the traffic straight to the gateway. So which means the return traffic is going to go back to the firewall, which is going to, the final implication is going to be asymmetric routing. So in order to guarantee that the traffic moving out from the VM goes straight to the load balancer, we need to make sure that UDR with the gateway it's off.
Great point. Yes, and this is where anytime you have an NVA, the flow symmetry becomes very, very important. And I'm glad you mentioned this because I was once on an escalation for exactly this issue. So great call out there. So now just the last part. So from here we got all the way up to with the 5 tuple hash here, and then this last leg bypasses the LB, as you see in the thing I've written in the flow I've written bypass LB. So from the firewall to the VM, it will bypass the LB, and so now we have a symmetric flow. And I also added this point that you made here. Daniel. So I think we're ready to go in the other direction then now.
Yes.
Okay. So trying to, oh, okay. So now we'll go from on-prem. So initiated from on-prem. So we go, so the blue flow animated flow is the one that's initiated. So let's follow that one. So from this VM, we'll hit the express route gateway. Again, there is a gateway subnet UDR that will take us to the load balancer. And from it will pick, let's say it picked this firewall. Here, the important call out is that there is no SNAT. We don't need to do SNAT. We can let it follow the default route for the return traffic, and it would still pick the same firewall but because of the 5 tuple hash.
Yep. It's important we always use one single load balancer, and the load balancer always going to know where the flow was initiated. Stick with the instance, the respective instance, and is always going to guarantee the flow symmetry.
And then the same logic applies that you want to not have that toggle propagate gateway routes set to no for this one as well.
That's correct.
So with that, let me just double check if I'm not missing anything we want to show here. Yeah, one of the things, Daniel, that I have run into and somehow it gets missed is that this NSG on the private subnet becomes very important for inbound the public one, and for outbound the private one. It often gets missed because when you look at from the perspective of this VM, when you look at from the perspective of this VM, even though outbound is allowed from the VM, it has to be allowed for inbound on these two firewalls. And
From the
that's
NSG perspective, right?
NSG perspective, yeah. So
Correct.
that always gets me, like you are thinking, okay, it's allowed from outbound, but sometimes, like if this is a brownfield environment and if you have NSGs kicking in because of some policy in your subscription, be sure that this one is allowing the right traffic. So from a troubleshooting perspective, I've seen that as an issue. And then, like we showed you, using the monitor in Palo Alto helps a lot. And with that, I think there are some outstanding questions. So when we meet with the Palo Alto team later in the video, we will add clarifications on some of the questions that we have. I believe that's the end of the video. Just for fun, Daniel, I'm going to light up all of these layers to show that this is really the inspiration behind the Art of the Possible series. So I thought I would show you this. And first time I did a load balancer sandwich design back, I think it was back in 2020 or something. This is what my notebook looked like. And this is where I decided that I wanted to untangle this flows, and I was looking for something, a tooling that would allow me to do that. And that's like the inspiration behind this this whole draw Art of the Possible series. Kind of full circle here.
Yeah, that's great, Nehali. It's a really a great improvement from your original diagram.
I can't believe that I was doing this now that I think about it. And especially, something like this where there is initiated traffic initiated from and return traffic both become so important, right? So which direction? So
Yeah,
awesome.
definitely.
So with that, we'll pause the video here and we'll pick it up with the Palo Alto team.
Thank you, Nehali.
Thank you. So today we have Bala from the Palo Alto team. So Bala, welcome again. And we're going to go over some of the questions that we have. While we were deploying the lab, Bala, we saved a few questions. So we'll just go over our questions. And I think we touched upon this a little bit, but here I just wanted to kind of go over the offerings very quickly. Which ones over here would you say, Bala, are related to the VM series? Certainly, this one we looked at, and this one is the panorama. Is there anything else on this screen that you think is VM series related? Looks
Um,
like maybe this one.
Yeah, the first blog that you see there that you highlighted, Nihali, that's the
Mm-hmm.
one where we could deploy the solution template.
Mm-hmm.
You can deploy a single VM series firewall, or you can also deploy the VM series firewalls in a in a high availability fashion using load balancers, which will be in active mode. And the one that you see on the right-hand side block, there is another offering which says VM series next generation firewall on the right side.
Oh,
The
okay,
last
yeah,
offering.
yeah,
So if you click on create the drop-down menu, I think it will only give you an option to do the BYOL. Yeah,
I
so
see.
that's the offering for the self-managed licensing, which is not like kind of like pay as you go, kind of like licensing, but it's the licensing based out of the credits that Palo Alto kind of like issues for this particular offering.
I see. But we can also create this and then later pick
Yeah, you
BYOL
can.
versus bundle. Okay,
You can do that. So the part of the template workflow, we've also included BYOL as the licensing, one of the licensing option.
got it. Perfect. So with that, the second question we had was maybe you can elaborate here is if you remember when we did this deployment, we were not able to do bundle one, and we decided to go with BYOL. So you had mentioned that you could walk us through what it would take, how to review what it did. So we do have the two firewalls deployed. Would you want to walk us through that?
Yeah, sure. So currently, if you go to dashboard, Nihali, click on
Mm-hmm,
dashboard.
mm-hmm.
And if you see here, basically the serial number is unknown. which means that currently, since we have selected the BYOL licensing, the licensing is still not active. We can also check that if you click on device.
Mhm.
So ideally, the state that we want our PAVM to be in is it needs to ideally get the serial number, get the device certificate, and get the licensing. If you scroll to your left, scroll down on the left-hand side options, and there should be a tab for licenses. And if you see here, there wouldn't be any licenses, right?
Ah,
The reason why this is the case is because for our deployment, we have selected the BYOL licensing option. The way BYOL licensing option works is from the customer support portal. So every customer would be having their own dedicated customer support portal. And part of the BYOL licensing methodology, we issue credits. We call them as flex credits. And we issue them part of the credit pool, which is kind of like assigned to the customer in the customer support portal. From that, using that credits part of that credit pool, any customer, what they would do is they would spin up something called as a deployment profile. In that deployment profile, they would mention for the PAVM how many codes they would need, what are the advanced subscriptions from Palo Alto that they would need to kind of like protect their environment. Like for example, if they're looking for mainly inbound protection, outbound protection, or if they're looking for any malware protection, they kind of like select all that advanced subscriptions part of the deployment profile. And once they create the deployment profile, they will be issued with something called as an authorization code. So now in the licensing management section, if you see the second option, which says that activate feature using authorization code. So once that authorization code from the customer support portal is generated after the deployment profile creation, you would enter that part of the, you would enter this authorization code here, which would kind of like fetch the licenses for you.
got it.
But
So it's not done through Panorama. It is done through your portal.
actually, there are multiple ways of getting the licensing, Nehali.
Mm-hmm.
One option is bootstrapping.
Mm-hmm.
Bootstrapping the like, for example, when we went through the workflow, there is an
Mm-hmm.
option to also provide some bootstrapping parameters. So let's say if a customer creates this deployment profile, and that's the recommendation that we usually give, they can bootstrap the authorization code, part
Right
of
here.
the bootstrapping options. Then they can also kind of like, if you click on the third option, they say like provide bootstrap parameters. Yeah, so they can kind of like provide the auth codes. There is an option to kind of like provide the auth code, but they can also kind of like have the activation done through Panorama as well. So there are multiple options, but the usual recommended option would be to kind of like bootstrap the VM series firewall with any authorization codes and also the Panorama information so that it kind of like gets connected to Panorama, gets the licensing, device certificates, etc. And serial number is also fetched from our customer support portal.
Got it. So the other thing that we noticed is without the licensing and without the serial number that you showed us, it did work. In other words, we were able to do everything, all of the testing we wanted to do. We didn't test any advanced cases with BGP or anything, which inbound, outbound NAT is what we tested. So is there a limitation on what we can and cannot do with this default setup?
Yeah, absolutely. So I think basically, if you like kind of like think about like few limitations around software updates, right? And also, again, the firewall is kind of like used to prevent any zero-day threats, sophisticated threats, and we need to make sure that there are latest content updates with respect to the signatures and everything on the firewall. So I don't believe without the licensing, you would be able to get the updated signatures. We'll be able to kind of like use our advanced subscriptions, kind of like prevent any of the sophisticated attacks without the licensing.
Got it. Yeah. So all of the features that you showed us in your presentation, the advanced security features
Yeah.
and signatures, we wouldn't be able to get. Got it. And so that brings us to the question that maybe Daniel, you could lead this question that we observed. So again, kind of to set the context, we picked this high resiliency design with load balancer. And from Azure side, what we saw versus what we saw on the VM on the Palo side. So I'd let you lead this question, Daniel, what we observed, and I can navigate and show this, set it up for you over here, what we saw in here.
Thank you, Nehali. That's right. Yeah, so the first question here is specific on the screen where Nehali is highlighting on the high availability general.
Mhm.
One of the first questions that we have is the checkbox enable HA and also enable config sync.
Mhm.
One thing that we ended up doing in our lab, we had to create the rules, the policies in both Palo Altos in order to make our lab to succeed.
Yeah.
And we just want to understand how this enable configuration sync works, and also the HA option. Should I, what each point should I enable or leave it disabled? Because that's the default after we get the template deployed.
Yeah, absolutely. So the enable HA here, Daniel, I believe is mostly for our active passive type of deployments. And usually in active passive type of deployments, to the outside world, I mean, the two firewalls would kind of like show up as one single firewall, right? So which means that any configuration that we make will be sent to the active HA firewall. And in the backend, obviously, since we need to make sure that there is a config sync between active and passive so that whenever the active fails, the standby kind of like kicks over and then has the same exact configuration. So that's the config sync option that you have right there. But mainly the enable HA is mainly for our active passive type of deployments. But for active active, which is kind of like front-ended by a load balancer, I don't think we need to make any configuration here because in that case, also, in the case of active active, like you rightly mentioned, we need to make sure that the policies are configured the same across the both active active, I mean, both of the firewalls. But the usual recommendation that we make to our customers is if you have more than one firewall in active active, generally use Panorama or our Strata Cloud Manager, which is the centralized management configuration engine where you could push the uniform policies across multiple firewalls at the same time, which kind of like maintains the config sync across the multiple devices which are in HA.
Makes sense. Yeah, and I think that's what we ended up discussing, Nehali,
Mm-hmm.
that Panorama would be potentially the way to go for making sure we have the policies synced between both instances, correct? And thanks, Bala, for clarifying that.
Yeah, thank you, Bala. Yeah, so that does mean that this enable config sync is not actually doing the sync in this scenario.
In the active active, no.
Okay, got it. And if we did, because if you see over here, it also says the mode is
Yeah.
active passive, but when we, like Daniel mentioned, when we look at it from the Azure side, it's active active because
Yeah,
both
yeah,
the
exactly. So actually, in fact, Nehali, this VM is not exactly sure, is not even aware of the other Palo Alto VM
Mhm.
because we kind of like deployed this in front of the load balancers. So load balancers are kind of like our main devices which kind of like are load balancing the traffic across multiple VMs. It's just that for an additional additional node or additional redundancy, we kind of like have multiple VMs so that we kind of like can make use of all the devices part of that HA pool. So here in this case, this VM is not even aware of the other VM.
Actually, exactly, because that brings up another point that we observed is that if you look at the VM, both
Mhm.
up at the top, um, both of these VMs are called FW1, and this one's also
Yeah,
FW1. So we had to make extra effort to make sure we were on the right firewall
exactly.
because they're both labeled. That
And even
was,
yeah,
yeah.
also when we are sending traffic between the two firewalls, you don't know which like what session kind of like lands on which firewall because again, like it depends on the load balancer algorithms, how they would want to kind of like hash that traffic across the multiple firewalls.
Agree. Yeah, we just observed the discrepancy between the naming. So if we sort this by type, there are two VMs, right? Let's see. So VM1 and VM2, right? So we thought that there would be something along those lines over here that we can differentiate at a higher level when we are doing administration. But I see your point that this is mostly done through Panorama or Strata Cloud Manager.
Yeah.
Okay, so that was one question. And then along similar lines, we had noticed that here under the interfaces, of course, at the OS level, we are doing DHCP, but somewhere, not sure if this is documented in your documentation, but from the Azure side, we would prefer that these VMs are set to static for the IP addressing. So let's, and Daniel, you can add more comments on why we would prefer that. So for example, if you see over here, the untrust NIC, here there should be something in the docs that said, once you're done deploying, toggle this and make it static. And Daniel can go over why.
Yeah, exactly. So our recommendation to change the stack is just to avoid, because if you leave it dynamic, if for some reason you stop and deallocate one of the VMs, and for example, you deploy a new VM in the same subnet, that new VM is going to check that the IP is available. It may take over that IP. So when you change this to static, at least we're going to guarantee if you're doing some sort of maintenance and the VM has to be offline, another VM or some other deployment is not take over that IP.
Yeah,
so that's the consideration.
Right, yeah. Makes sense. So the option that we see on the PAVM, which is dynamic, that's going to be the IP that Azure is going to give to the PAVM. So it's going to be the same IP. So whatever Azure gives it, it's going to take it.
So this is okay. This side is okay. It's just that in the process, at some point, we should have our customers make it static.
Yes, makes sense.
Or the template could do that as well, Daniel, right?
Correct. The template exactly. If would be easier if the template takes that in consideration during the deployment, because we can set that during the deployment. Makes sense, Bala?
Thank you, Daniel. Does that make sense, Bala? Just want to make sure that we are, because we are just sharing what we see from Azure side and what we see on your side. Perfect. And another observation is, let me go into one of the load balancers. So if we go into the ingress load balancer, and let's look at the default rule. So we didn't touch this one. This is the rule that came out of the box. Actually, we did change it, right, Daniel, over here. So if you want to talk about the session, it comes with the session persistence of, what was it? This one? Yeah.
Yeah, it was the last one, source IP and protocol. Yeah, but when we deployed the template, we found out that this specific load balancer gets with the session persistence with the last option, source IP and protocol selected by default. And what that's going to, the behavior is going to be every time that we send from the same client IP, we're going to persist to the same instance, right? So, and our goal here was to make it active. So when we did some tests, we didn't find, we find out that only one instance was forwarding the package from the outbound to the target VM. And when we took a look on the setting, we switched to the none, which the none says no session persistent, which means now we're going to distribute based on the 5 tuple, we're going to distribute evenly across both instances. So that was the other observation that we saw. Is that in specific region? Do you know why that was selected from the Palo Alto side, or?
Session persistence is there are a few use cases which the customers kind of like ask for this option, Daniel. Because especially let's say if there is a long-lived session or they don't because for some especially for TCP related connections, right? You would want to kind of maintain that session persistence across one instance rather than kind of hashing it across the multiple so it kind of depends on many factors that I mean, if that session is kind of like a latency prone session, or do we can we kind of hash it across multiple instances? So there are few use cases where the session persistence is kind of required. So that is the reason why we have that option. But I'm not too sure if that is kind of the default option, meaning if we kind of have that as default with source IP and protocol.
Yeah, I think we deployed multiple times, correct, Nahali? And we always got the same setting there.
Okay, that's default. I see. Got it. I can kind of check and see why that's a default option rather than kind of going with no session persistence. But session persistence has been kind of one of the huge asks from our customers to kind of have session persistence, session resiliency, etc.
Yeah, I can add from the long-lived sessions. I agree with you. In the past, we had some issues because our load balancer at some point didn't issue a proper timeout or TCP reset, and that could cause trouble. And in one of the workarounds, we recommend the customers to do that source IP and protocol to overcome that, to keep the persistency.
Right.
However, we enable, there is a new option in the load balance called enable TCP reset, which means it's going to instruct the client after the proper timeout when you have that checkbox that the client now needs to start a new conversation, TCP conversation.
Right. Makes sense. Yeah.
So maybe something that maybe it was at some point and never got changed, but that's something that we want to highlight if the customers they see some behavior and they expect the traffic to get evenly distributed across the instance. They can take a look and make the proper decision based on the session persistence, based on their needs as well, as you mentioned.
Exactly. And then also in some cases, Daniel, we would want to avoid asymmetric routing. There might be a few scenarios where we could also hit asymmetric routing. So that's also one of the case where if you want to avoid any asymmetric routing, we can kind of enable session persistence.
Yeah, that's a good call because in our case, I believe, Nehali, we did that change because on the load balance sandwich, right? We had to use the approach of the floating IP, and also we replaced in the DNAT rule the return traffic to go back to the same instance. So we do technically DNAT
with the SNAT.
Yeah, exactly. So in kind of we overcome that. But I agree with you, Bala. That would be also another way to guarantee symmetry without make the change. But we could, as we demonstrated during our lab, that we can tweak the DNAT rule to make sure the session persistence keeps to the same firewall. Even change that to none.
Yeah.
So which means we get the both. Both of the best worlds, because we evenly distribute the traffic across multiple instances, and also with that setting, we guarantee the symmetry of the instance.
So here, if you see, and let me trigger it from the other side. If I'm hitting you could see it cycles between 2.4 and 2.5. So this SNAT setting ensures that it goes to the right firewall.
Yep, makes sense.
Yeah, so another question that I had on my list is just for the benefit of our viewers, which are coming from Azure background. Is there a good place? Have you been using Monitor for troubleshooting quite a bit? Would you have any tricks or tips based on your field experience, Bala, that you would like to share for troubleshooting? We shared some stuff on the Azure side. I'm thinking maybe if you have anything on the
I'll
Palo
take it.
side.
So out of the box, Nehali, you wouldn't see the logs here in the traffic. The
Mhm,
reason being is that first, on the policy, we need to ensure that the logging is enabled on the security policy.
mhm,
Only once the logging is enabled, that's when, yeah, you go to actions and
mhm,
you see there is a log setting to enable log at session start, and that's when the logs show up, right?
mhm.
So once the logs show up, basically we will be able to see if the complete reachability is working fine, meaning if we have the layer 3 reachability or not. If the status doesn't show this session as incomplete. So if you go back to the monitor page, and if you see the application here, it like you see like some of the applications from the source 168.63 to destination 1.5, the application is incomplete. So meaning that I think that is the health probes, I believe, but there is also from 79 to 124. So those are the applications that we were not able to identify. Maybe those are not coming from I think 79 is kind of like coming from the internet. So we are not able to kind of like perform the application identification on those. But ideally, we should be able to kind of like see the application. If you see the last but three and fourth, we were able to kind of like correctly identify the web browsing application. So ideally, what I would say is kind of like look at the application, what kind of application it is, what's the policy setting, if it's allowed or denied, and also what's the rule that it's kind of like hitting. And you can kind of like see pretty much all the details in this detailed log view. And but this is only going to be mainly your traffic logs, right? But if you
Mhm.
want to look at any threat identification or any URL filtering, you have like the other different sections. Like for malware, we have wildfire. So pretty much once you have the advanced subs enabled, you should be able to see all that vulnerabilities, exploits, which can kind of like get detected by our ATP, AURL, ADNS. So all that security related logs, all your threat logs will be present in that respective section.
Awesome. Yeah, that's good to know. And then anything that you have seen in the field with the common issues with this LB sandwich design other than what we've discussed about symmetry?
Mainly for the LB sandwich design, one issue is the symmetry. They wanted to make sure that there is no asymmetrical routing, but mainly they would want to understand that like the ingress and egress packet flow, like from the internal applications to the internet and from the internet to the internal applications. And basically pretty much they kind of like integrate this with like let's say for example if they would want to go with application gateway or like any NAT gateway, they can kind of like integrate with that as well. And yeah, pretty much there no any like specific issues. They can this design kind of like works perfectly. So, but mainly like if there are any like traffic routing related issues, they can kind of like we can kind of like make sure that the traffic path is not is kind of like the packet is kind of like taking the right traffic path as intended.
Awesome. Yeah, we did cover the NAT gateway in our lab, and so that's a good call out. Daniel, anything else that I missed? I'm just going through my notes here.
I think you covered pretty much everything, Nehali.
Thank you, Daniel. Yeah, so I just found one. item here. Yeah, so if you remember, from once we pick this one, there is another setting. I'm trying to remember where. Oh, yeah. Uh, just for completeness, maybe you could talk about this drop down. So at a higher level, we pick high resiliency with load balancer, but I do see that this use case, dedicated inbound, dedicated outbound, right, Daniel, we've seen a lot of our customers do this. So just wanted to see your insights, Bala. What do you see as most common
Yeah.
and
So that last option, Nihali, is a set of 4 firewalls. So
mhm.
what usually customers do is if they would want to kind of like separate out the firewalls with respect to the inbound and outbound traffic, they dedicate a pair of firewalls to handle the inbound traffic, and they dedicate the pair of firewalls to handle the outbound traffic. So we have kind of like redundancy for both inbound and outbound firewalls. So in case like if there is like lot of traffic that needs to get inspected, even the customer has an option to kind of like segregate that traffic flows as well.
Got it. And do you have, and I haven't checked, but do you have diagrams
Yeah,
for
yeah, yeah.
each
So
of
it's
these that you can share with us? I'd put
yeah,
it in the link below in the description.
yeah. Let me share the link. Actually, we have an external facing document. So
Daniel, any other question on these four designs? I think the green one is the one that we've seen the most common.
That's right, Nehali. It's usually what I see in most of the customers is a dedicated set of Palo Altos for east-west traffic and another set for public.
Perfect. Yes.
I put the link in the chat.
Okay. All right. And we will share this link in the description as well. Okay, so it covers all the four different
Yep,
deployments,
it
right?
has.
Because I don't have all of the designs in the draw IO. We shared the sandwich design, but it's good to have this link.
Yep.
Awesome. I think Bala, we're good. Thank you for being available and helping us through the Q&A session.
Yeah.
One last thing before we break is, what are your thoughts on um, you know, getting us a license where we could kind of test out some of the features like VPN and BGP.
For if we go with the bundle one option, Nihali,
Mhm.
usually we get like 30 days of like free licensing. Like once we kind of like subscribe to the software, the bundle one, the pay as you go will give like 30 days of free licensing. That's one option. The other option is, I think since Microsoft is a partner, I can check with our partnerships team to see if we can issue some eval credits for you so that you can use. Do you have a customer support portal by any chance?
I don't have it. I think for NGFW, Cloud NGFW, they have done something similar for us. So if you could do that, I think that would be good. So we could see the other side, the panorama side, or kind of do it the way our customers would be doing, if you know what I mean.
Yeah, understood. Yeah.
Yeah, so definitely, yeah, check on that one because we would like to use the VPN functionality, maybe the BGP functionality. Would that work out of the box? I haven't tested it, but that it should work, right? Without
Um,
any extra license.
I think it should.
Okay.
Um, yeah, I think it should. Yeah.
Yeah, but ideally, like we would like to mimic, so we don't have to set up VPNs on both sides, some sort of HA functionality. Like if we can push that config, that would be good.
Right, right.
So,
Absolutely. And also for the licensing, Nihali, I think after 30 days or something, I think the VM kind of like reboots continuously if you don't have an active license. So that's
mm,
one thing to kind of like keep in mind as well.
That's good to know. Okay.
All right, perfect.
Thank you, Bala. Thank you for joining us today,
Yep.
and appreciate the time. Thank you, Daniel, for being available today as well.
Thank you, Nihali. Thank you, Bala.
Yeah. Thanks,
Appreciate
Daniel.
it.
Appreciate it. Thank you.
So next